For our first example, we're going to look at the function x squared times cosine 1 over x. Now, this function is not defined at 0 because we have the 1 over x, but we're going to define it to be 0 when x is equal to 0. So this function is defined on the entire real line. So is f of x, defined in this way, differentiable at x equals 0? Well, the only question we need to ask ourselves is, does this limit exist? And if it does exist, then that'll give us a number that is the derivative of f at 0, so f prime of 0. So let's do a little arithmetic on this. Let's note that f of x minus f of 0 over x minus 0, which I'll just write as x, is equal to f of x is x squared cos 1 over x. Obviously, this is when x is not equal to 0. And then minus f of 0. But if you plug in 0, you get 0. If x is a 0, f is 0. So f of 0 equals 0. So we get minus 0, which I'll leave off, over x. So one of the x's cancels, and we get x cosine 1 over x. So does the limit of x times cosine 1 over x as x goes to 0 exist? This question has now been simplified to this. And in fact, it does. We've seen problems like this. I don't recall if I proved it in class or if you did it for a homework problem. But why do I know this limit exists? Yes, I know the limit as x goes to 0 of x is equal to 0. That's trivial. But cosine 1 over x in absolute values, it's less than or equal to 1. Cosine is between -1 and 1, so it's bounded. So we remember that if we have two functions being multiplied together, where one of them has a limit, a real number limit, and the other one doesn't have to have a limit. In fact, this one does not have a limit, but it's bounded. In this case, we know that this is equal to 0. So the answer is yes, and we can say that f prime evaluated at 0 is equal to 0.